So, Pasquale, Stefan, Enza, you have 40 minutes to present us the BIOVEXO project.
So welcome again, everybody. I'm going to explain. I will explain what we have done in BIOVEXO during this 5 years project, from the lab to the field. How we try to develop different biopesticides. But first of all, this is a project granted by BBIGU, it's now CBEGU. It's a €6,600,000 project with industry like Globachem, Domka, Assess Bio, some RTOs, and also academia. And our objective were to develop some biopesticide to reduce the disease pressure caused by Xylella. Disease severity, and also to protect on the long term olive cultivation, but also almond trees in Mallorca. And to secure jobs, because farmers they lost a lot of jobs because of the Xylella disease, especially here in Puglia. And for that, we started not from scratch, but we had some solution in our pipeline, in our different laboratories, with some beneficial bacterial strain that can be antagonist or not to Xylella, some plant extract, microbial metabolite, and also an antipathogenic fungus. And the idea was to test this solution as preventive or curative against Xylella directly, but also against the vector. So to have different approach for sustainability. Sorry? Okay, like that. And for that, we had different work package in the project, starting to evaluate at a small field scale trials, some biopesticide targeting the vector or targeting the Xylella, also to upscale and formulate the different biopesticides, to test on the large field scale trials, and also to optimize delivery and to assess about the sustainability of the product and the toxicology and the toxicity. The result obtained so far, what we got. We upscale and formulate different biopesticides. We start with different one at the beginning, but we select some to go further into testing on the large-scale field trials. We tested spray or drip irrigation on also endotherapy, on almonds or on olives against Xylella. We analyze also the life cycle analysis, and we determine part of the mechanism of action. When we know that there is some biopesticide working or not against Xylella or against the vector, what are the mechanisms involved? And we start with small-scale field trials, different solutions in olive orchard in Puglia, on almonds and olives in Mallorca. We identify the best application method, how to apply the different product. Some products should be used with drip irrigation, some with a foliar spray, some with a endotherapy, and as curative or preventive. And every 6 months, we monitor by qPCR the Xylella population, but also the symptom. What we got at the beginning, we start to see something on plant vigor. There was no solution as curative, and as preventive, there was no symptom at the beginning. But we select some solution named formulated PAGN, onion extract, and a bacterial strain, Pseudomonas PV8, for further testing. For the insect vector, we made some lab tests to confirm efficacy on the laboratory condition of some substances, identification of the best application method, so interval of application, the rate of application, the dose range, before to select some V biopesticide targeting the vector for further application. We started with 3 biopesticides targeting the vector. But at the end, we select only one, which is named Sankari from Grobachem. And you will see some results later on about this biopesticide targeting the Philaneus spumaeus. And here, on the laboratory condition, you have the control, so untreated insect. You have several dilutions of the Sankari product, and you can go up to 100% mortality of juvenile or adult insects after application of the product Sankari, under laboratory condition, first. And the mortality was assessed different minutes after treatment, 1 minute, 2 minutes, 30 minutes, 60 minutes. And what we have done just after, with the different X biopesticide, remember, targeting Xylella symptom of the population, and the V biopesticide targeting the vector, we needed to upscale the production to apply sufficient amount of biopesticide in large-scale field trials. And also to optimize the formulation, to put some adjuvant, also to increase the shelf life. And it was a lot of work by industry. It doesn't work. And what we have done so far on optimization of formulation. For the X biopesticide, we got 2 products based on onion extract from Domka, trophic liquid evolution IT, that can be applied as foliar or drip irrigation, or trophic powder endo for endotherapy. The strain Parabiocorderia phytopheromone strain PHGN that has been shown some nice result in California against peel disease by Stephen Lindo was upscaled to 6,000 liter, formulated for extended shelf life, suitable for large-scale field development. And for the V biopesticide, robust formulation of Sankari with packaging and validated storage stability. And then what we have done, so this took several years already, since the beginning of the project. And I told you this project is 5 years. It has started in 2020, will end in December this year. Then we evaluate this product in large-scale field trials. And now Pasquale will show you this result, what we get on the field condition. We have a lot of different plants. Then we will talk about IPM strategy, and I will come back after for mechanism of action and toxicity. Pasquale?
Okay, thank you. The worst that could happen to me is to work in the field, from the lab to the field, but it was a challenge to me to work on this. And I coordinated these large-scale field trials that, as far as I know, this BIOVEXO represent the largest project working on such a big number of plants. We work on more than 100 of plants in the fields. And we tested these 2 biopesticides for Xylella, against Xylella, and against the vector in olive, in almonds, in Italy and Spain. This is a real-life evaluation, because I learned that finally you should move in the field to evaluate the efficacy of every product. And in 2 different approach, a curative and the IPM approach. This is a summary of the field trials that we have ongoing, in Italy. There are 2 curative field trials in Oria and in San Vito nei Normanni, so in the epidemic area. These are plants already infected at the start of the trials, 30 years old olives. while these were planted by us during the BIOVEXO project in San Vito dei Normanni. In Francavilla Fontana and in Squinzano, we have another 2 field trials which deals with an IPM approach, an approach that combines the use of the biopesticides against Xylella and the biopesticides against the vector. These are the field trials in Mallorca. These are made in olives, but we give up with these trials because they were not very infected. And we moved and have the better results in field trials on almonds, and you can see here the field trials in Santa Maria del Camino. Sorry. The field trials of Oria. The cultivar is susceptible, Cima di Melfi. These are the treatment that we tested in the fields. Plants were already infected with symptoms at the start of the trial, and the 2 biopesticides were the onion extracts and this formulated PSG and these endophytes, with 8 treatments per year. The results that I'm going to present are related to a period of 4 years, because you need this period to get at least significant results in this kind of plants. Plants are 120 plants randomized in a classical randomization that are applied in field trials. This is the field trials in San Vito dei Normanni, 168 plants against randomized, the same treatments, the same products. These plants have no symptoms at the start of the trial because we planted this in 2021, correct, Enza? 2021, so we follow it. These are, to me, these are very precious, these orchards. I would like to continue to maintain these orchards beyond BIOVEXO, because we know the history of all these plants for 4 years, because every 6 months we monitor Xylella by symptoms and also by quantitative PCR. So we know the evolution of the epidemic in the field for all these years. And another point that I want to highlight is that these curative trials have been carried out without any control of the vector. So the plants are exposed to natural infection without any control of the vector. These are the results in Oria. We observed an increase of the symptoms throughout the years. These are of distribution of symptoms. The owner pruned the plants in 2 different times throughout the trials, and we consider this was an heavily pruning that was done last year, and we consider this as a part of a possible IPM approach. We evaluate 2 kinds of symptoms. New symptoms, that means the symptoms occurring in the year, and desiccated shoots or old symptoms, so symptoms that belong to the previous year, so that means branches without that have lost the leaves throughout the years. And we also evaluate another parameter that I'm not going to present, which is plant vigor, which is very important for one of our two products. Okay. These are the results in Oria, and you can observe this is a sort of way of expression of symptoms, the area under disease progress curve. It is a cumulative observation, evaluation of the symptoms in the whole period. What we observed is that new symptoms in Oria were significantly reduction as by this statistical analysis in this case, while desiccated shoots, they were not significantly reduced. The other field trials is San Vito dei Normanni. Of course, we observed an increase of symptoms, particularly the last season was very drought, which was very hard for this trial to maintain. It's a curative trial. And here we again observed a reduction, significant reduction of new symptoms and all symptoms for one which were significant for one of the two biopesticides we tested, which is the formulated PSGN. I remember that, as Stefan said before, formulated PSGN is a Parapurcoldiria phytophyrmans strain PSGN that was already described in California, working in Pierce disease. It was described by Stephen Lindov in California. He's already working on it. Oh, cacchio. No. Perché? Okay. The bad news is that we observed no statistically significant difference in Xylella concentration across the years. So there is a sort of reduction by the formulated PSJN, but it's not significant. So we were not able to eliminate the pathogen from the infected plants. That is a limit, but I think it's a limit of the particular pathosystem that we are dealing with. So we do not guarantee. This is particularly important because people, as Donato commented before, try to propose some mitigation of the disease in the buffer area. That is not possible to use pesticides that do not eliminate the pathogen from the infected plants. I was not so very. I wanted to expand our information about the observation about these plants, not only limited to the visual observation, because what you have seen before was related to symptoms observation on a scale to 0 to 5, and we wanted to, and we are also introducing this evaluation in all our activities in the field. We want to introduce some numbers, some real numbers in the evaluation of the plants infected by Xylella. One of these is the use of the evaluation of the stomatal conductance. Xylella induce a drought stress in the infected plants. That means that block the xylem and also the plants react by closing its stomata. We have also published this data on a previous paper, and the instruments to evaluate this is the porometer, is the instruments that evaluate the opening of the stomata in the plants. And then we can compare the status of the infected plants against the healthy plants. If this difference, of course, is close to 0, that means that the infected plants is not suffering because their stomata are similarly open as the infected plants. And what we observed in this case, it was a confirmation of the efficacy, I would say, of formulated PSJN. This difference was significantly different in plants treated with formulated PSJN on a number of plants. These data are related to a number of plants of this field trial. If stomata close, the temperature of the plants increase because there is no exchange, gas exchange. So we also evaluated, in contemporary, we also evaluated the temperature of the canopy of these plants of San Vito dei Normanni in different situations, and we observed against that plants treated with the formulated PSJN are colder than the untreated plants. So confirming the data from the porometer, from the stomatal conductance. This is a final summary of the progress of the symptoms throughout the time from March 2023 to July 2025. Every line on the graph corresponds to the full line is correspond to the formulated PSJN, while the break lines corresponding to the plants treated with onion extracts. We observed in Oria that new and old symptoms were reduced in treated olives in comparison with untreated olives. So these data are the treated plants subtracted by the untreated plants. In Oria, this reduction was of the 11.3% for the formulated PSJN and 10% for the onion extracts. And this is the situation in San Vito dei Normanni. In these young plants, we observed a reduction of new and old symptoms in olives treated with the formulated PSJN for the 27% and 25% respectively in new symptoms and old symptoms, as I described before. These are the results of our field trials in Mallorca on almond trees. This is the orchard in Mallorca. And on July of this year, our colleagues in Mallorca, they evaluated the symptoms on the same scale that we use in Apulia. And they observed again that formulated PSJN reduced the symptoms in plants treated with these products and also with the onion extracts. Even also in Mallorca, as in Apulia, the increase of positive samples increased during the time as evaluated by quantitative PCR also in Mallorca. So the highlights is that our formulated PSJN slowed down symptoms on young plants when application was started at the early stage of infection, particularly in olive. These products improves the stomatal conductance and plant vigor. We have also some trials ongoing to evaluate the vigor induced by this plant growth, because PSJN is a plant growth promoter bacteria. Reduces symptoms in almond, and similarly in onion extracts there are reduction of new symptoms in olives and reducing symptoms in almonds. We confirm that none of the two biopesticides lower the Xylella population with statistical significance in infected plants. And I think I stopped with this. So, Enza.
Good morning to everyone. I linked the presentation of Pasquale. As said Pasquale, in two curative trials in Oria and in San Vito dei Normanni, we have applied specific measures for the control of the bacterium with applied PSJN in spray and onion extract in drip. But for the entire period of the trial, from 2022 to 2025, no specific measures were applied for the control of the vector. while in this period we have evaluated in both trial the density population of Philenus spumarius and also the percentage of the insect harboring the bacterium. As evident in this slide, in both trial, in San Vito dei Normali and in Oria, the density population is very high, but in particular, the percentage of positive insect to the bacterium is in 2022 and in 2023 more higher than the mean value that we have obtained in other sites that we have monitored in Lecce and in Brindisi province. So this high density population and this high percentage of insect positivity to the bacterium probably influencing the transmission events. And so we have not the possibility to verify the reality effect of the tested product against the bacterium. From 2022, we have set up 2 field trials in infected area, one in Squinzano and others in Francavilla. Very big field trial, about 1 hectare, with about 400 olive trees that were planted in 2022, and the plants were exposed to natural infection of the vectors. In this field trial, we have evaluated the effect of the both selected products, PSGN and onion extract, against the bacterium, and they are integrated with specific control measure against the juvenile stage of the vector using the product based by pelargonic acid, Sankari, and also the specific application against the adult of the vector, also using at different rates a biopesticide based on pelargonic acid and compared with plot treated with chemical insecticide, acetamiprid, this authorized product for the control of Philenus spumarius. In this plot, each treatment against the bacterium were repeated a lot of times, 18 times, and each plot consists of 16 plants. As in curative trial, we have carried out 8 treatments each year, starting in March up to November, and the application Okay. The application against the juvenile stage of the vector were applied during the spring when the juvenile stage reached the third, fourth instars. 2 applications in 2 big plots, about 2,015 square meters, reported in the slide in blue, and this big plot were compared with a big plot untreated for the juvenile stage. In each big plot, 14 transect is a method to evaluate the density population of the juveniles were considered, and we have evaluated the number of the split, the number of individual in each split. Only in one trial, in Francavilla, we have evaluated the effect of GrowBP applied against the juvenile stage, and we have obtained good efficacy with an Abbott index ranged about 50 to 54%. Lo fa lui. Ah. Okay. Regarding the adults, we have treated four plots, 2 plots with organic product, pelargonic acid, and 2 plots treated with chemical insecticides. The application were carried out when only one individual of Philaenus spumarius were captured among the 32 sticky traps placed along the edge of the untreated plots. And the application starting when the adults move from the ground vegetation to the olive canopy. And then we have carried out application with the GoBP each 7 to 12 days, while with acetamiprid each 12 to 15 days. Okay. No infected plant after 3 years after the starting of the trial, we have collected a sample from the shoots, and we have evaluated the percentage of infected plants within each plot. As evident in this slide, no infected plants were detected in plot treated with chemical insecticides 3 years after the start of the trial. No infected plants were recorded in formulated PSGN untreated against the adult of Philaenus spumarius, with an Abbott index of 100%. An evident reduction of the percentage of infected plants were obtained in plot treated with formulated PSGN and onion extract with an Abbott index ranged to 50 and 70%, in plot treated and integrated with product based with pelargonic acid for the control of the adultus vectors. Regarding the field in Squinzano, we have carried out the application against the juvenile stage and the adults, adopting the same method adopted in Francavilla. In this case, we have not observed difference among the treatment against the bacterium, formulated PSGN onion extract, as compared to untreated check in plot untreated against the vector, while good results were obtained when we have integrated the application against the bacterium and integrated against the vector in both conditions using chemical insecticide with an Abbott index of 18%, also integrated with chemical organic product with an Abbott index of about 50%. No results were obtained in this case using onion extract, regardless the treatment against the adult vectors. In synthesis, using saccharine, pelargonic acid, for the control of the juvenile stage of Philus spumarius, we have obtained an effectiveness of about 50%. An integrated pest management can reduce the percentage of infected plant, in particular when we have used a formulated PSGN, and we have integrated this treatment against the bacterium with a specific application against the vector. In both the conditions, both using chemical insecticide and also using organic product. Inconsistent results were observed using onion extract. No effect in one trial, while a strong effect in other trials in Francavilla, where the percentage of infected plant was reduced about 76% when it is integrated with using of saccharine based with pelargonic acid against the vector. So in synthesis, these results appear promising. The integration of in preventive trial of specific measures targeting the bacterium, but also the vector, can reduce the progression of the infected plant and the disease. But I think a further long-term study is necessary to verify the effectiveness of this integrated combination in the long periods. Thank you to it all for the attention.
This is not finished, sorry.
5 minutes?
Yeah,
Stefan?
sure,
Okay.
sure. So we show you some results from the lab to the field, and now I would like to come back to the lab to determine what was the mechanism of action with the different substances, the different product. So what we assessed first, if there was antagonistic activity against Xylella on petri dishes, formulated PAGN or PAGN alone, there was no direct antagonism against Xylella, only onion extract. But we also evaluate the effect of the biopesticide, the different biopesticide, on the plant immunity, the plant transcriptome, the gene expression of the plants after application. Also, if our biopesticides change the plant microbiome, the different component of the plant holobiont of olives, if there was an increase or decrease of other kind of microorganism associated with plants, and also on the insect microbiome. And we evaluate also if our solution were persistent or not in the environment, like with formulated PAGN. This is just one example of result from the lab with plants under greenhouse condition. And what we saw with formulated PAGN. When we applied formulated PAGN on plants, there is an increase of gene expression related to plant metabolism, carbohydrate metabolism, photosynthesis. And when we put the Xylella on the plants, it looks like the plants have less stress when the plant is pre-treated with formulated PAGN in comparison when you have plants treated only with Xylella, where you have a lot of stress in the plants. And we have done also some other things on the plant microbiome. We don't have enough time because I have now only 4 minutes, I think. And what we wanted also to assess, we had some nice results from lab to the field. Reduction of symptom, no reduction of Xylella population with the X biopesticide directly as curative. Combination of different product with V biopesticide and X biopesticide on IPM strategy when you saw a reduction of the infected plants. But what is very important also is to assess the sustainability of the product and the toxicology and the toxicity. So we analyze the life cycle of each product, if there was less energy cost when we make the product compared to existing product. Sorry. And so we have done also toxicity evaluation on the human, on the environment, selection of the best solution. And we know that our products are non-toxic. And in a nutshell, to finish, yeah, we formulated PAGN. We have a reduction of some symptoms in San Vito de Normandie. After 4 years of application, we know it's improved also plant vigor. We saw better green plants. Onion extract also improves tomatal conductance, plant vigor, reduce appearance of new symptoms on olives and almonds. Some carrier reduction of the juveniles and insect adult. And in IPM strategy, we saw also a reduction of percentages of infected plants when we combine with chemical solution or biological solution. There is, unfortunately, no product yet on the market for the farmer. We are close to market entry, but have in mind that this took 5 years to start from the development, innovation, and to get this result from the lab to the field. And I would like to thank you very much for your attention. There is only my name written, but we are all here from BIOVEXO together with this result. Thank you very much.
Thank you so much. So that was some insight into the BIOVEXO project. We have, I think, time for a couple of questions before we break for lunch. So please briefly introduce yourself.
Yes, thank you very much. I'm Fabio Gatti from Wageningen University, social scientist. So I was very curious about the product that you developed, and I had a few questions in mind. One, I was just curious, did you try also to apply it on old trees, like centuries old trees, rather than just like young, and see if...
No.
And see if there is an effect. And then, I have a second question, but maybe it's a little bit provocative. Why do you call it a biopesticide if you don't see a pesticidal effect? If you don't see a decrease in the density of the Xylella in the tree? And you, yeah, to me, this is just like, how does this compare with other products that have been used in the region that show a similar reduction of symptoms, and in some cases also a partial bactericidal effect? So does this product outperforms those? Thanks.
It depends of what you intend as a bactericide effect, because one of our products, onion extracts, has a bactericide effect in vitro. So you should be more precise if you ask. If this has a bactericide effect, but in the plant, I want to see if it reduces the population size of the Xylella. So this is the first. No, we have not tested monumental trees, but our trees are 30 years old. The one in Oria, they are 30 years old. We have not tested initially, perhaps also, I think, as my comments, consideration, that more can be done in the way of application. So a monumental trees is a difficult trees. There is another part that we did not mention, that we tested endotherapy with this product during the project, because endotherapy could be applied perhaps better on monumental trees, but unfortunately it was not better, the efficacy of the products by endotherapy with respect to the spray application or drip application as we did.
If I can add something for the question regarding the biopesticide, we have seen both effects. Biostimulant effect on plant vigor And for biopesticide, even if you don't reduce the Xylella population, but you reduce the disease symptom, it's still a biopesticide in the definition. But we have seen both effects, plant vigor, reduction of symptom, according to the product, of course.
Thank you very much. Thank you for these two speakers. Very, very good presentation. Very interesting results. My question is, what is the possibility for BIOVEXO to share the results or part of the results with EFSA for the risk assessment? I understand that you are bound to the industry, you need to publish, but if, yeah, maybe something is already published, but yeah.
That is a sensitive question. That is a sensitive question. Indeed, the difficulties in working on this such project is to work with companies. As a research scientist, I suffer in this condition. I should be honest with the people from the companies that is in the hall. Because there are conflicts, there are interests also, honest interest of the companies in this stuff, in this story. We are trying to publish these results. However, we are trying to publish these field trials results. The paper is already written. Now they are partner are reviewing this for a final. Also because as a scientist, I feel the obligation to share these results, even if they are not completely a miraculous solution, but perhaps someone after me could use this data to better modulate the use of these products. Regarding the data, if we publish these field trials, of course we should publish even in the Zenodo, in the EU repository, we should publish the Excel 5 that reports all our field observation, quantitative PCR data. So this should be published, and then perhaps this could be useful for EFSA to have numbers to work with. Did I answer to the question?
I think, Stéphane, you wanted to add something?
Also, I forgot to say that the results, the publication with the curative approach is on my computer. I'm a bit late, a few days. It will be submitted soon.
Okay. Final question? No? We're good? We're hungry? Yeah. All right. So thank you so much, Enza, Pasquale, Stéphane, for having shared these insights on the BIOVEXO project.